When astronomers describe the large-scale structure of the universe, they often use very simple assumptions. A sufficiently large fragment of the cosmos should be more detailed, just like any other reusable fragment. This assumption is called the cosmological principle. It states that on very large scales, the universe is homogeneous and isotropic, meaning that matter is distributed evenly and has no preferred orientation. This idea works remarkably well. Galaxies form clusters, clusters form superclusters, and these connect into vast cosmic filaments separated by enormous voids. Together, they create what astronomers call the cosmic web. But even this web has limits. According to standard cosmological models, structures larger than about 1.2 billion light-years across should not exist. Gravity simply has not had enough time since the Big Bang to assemble something bigger. And yet, something far larger may be out there. A wall across the sky. In 2013, astronomers analyzing gamma-ray bursts noticed something unusual. Gamma-ray bursts are extremely powerful explosions associated with massive stars collapsing or neutron stars merging. Because they are so bright, they can be detected from enormous distances. When scientists mapped the locations of these bursts in a specific region of the sky, they found a surprising concentration. That region appeared to form a gigantic structure stretching across the constellations Hercules and Corona Borealis. This structure became known as the Hercules Corona Borealis Great Wall. Its estimated size was staggering, roughly 10 billion light-years across. To put that into perspective, the entire observable universe is about 93 billion light-years in diameter. This single structure would span more than 1/10 of the visible cosmos. It should not be possible. What exactly is it? Despite its dramatic name, the Hercules Corona Borealis Great Wall is not a literal wall made of solid matter. It is a region where galaxies, galaxy clusters, and energetic events appear far more densely concentrated than average. It exists at a distance of about 10 billion light-years from Earth, meaning we see it as it was when the universe was much younger. The discovery was based on statistical clustering of gamma-ray bursts rather than direct imaging of a continuous structure. That detail is important. Unlike nearby superclusters, which can be mapped directly through galaxy surveys, this immense formation is inferred from patterns in high-energy events. That raises a critical question. Is it truly a single coherent structure, or is it a statistical illusion? The scale problem. To understand why this is controversial, it is necessary to imagine the early universe. After the Big Bang, matter was distributed with tiny fluctuations in density. Over billions of years, gravity amplified these fluctuations. Regions slightly denser than average attracted more matter, eventually forming galaxies and clusters. But gravity works at a finite speed and over finite time. There is a maximum scale at which matter could have clumped together since the beginning of cosmic expansion. Standard cosmology predicts that beyond roughly 1 billion light-years, the universe should smooth out. The Hercules Corona Borealis Great Wall is nearly 10 times that size. If it is a genuine, physically connected structure, then either our understanding of cosmic evolution is incomplete, or rare statistical fluctuations can produce much larger patterns than expected. Both possibilities are profound. Other giants in the dark. The universe has surprised astronomers before. There is the Sloan Great Wall, a massive filament of galaxies stretching over 1 billion light-years. There is the Huge Large Quasar Group, another enormous structure mapped through distant quasars. Each time such a discovery is made, it pushes the boundary of what seems acceptable under cosmological theory. But the Hercules Corona Borealis Great Wall is in a different category. Its proposed size is so extreme that it challenges the cosmological principle itself. If the universe is not homogeneous at the largest scales, then some foundational assumptions may need revision. Could it be an illusion? Science moves cautiously when dealing with extraordinary claims. The data behind this structure comes from a limited sample of gamma-ray bursts. These events are rare and unevenly distributed in the sky due to observational bias and detection limits. It is possible that what appears to be a massive connected structure is instead a coincidence amplified by small sample size. Large-scale statistical anomalies can occur, especially when dealing with extreme distances and incomplete data. Some astronomers argue that with more observations, the apparent structure may fragment into smaller unrelated clusters. Others remain open to the possibility that it represents something genuinely new. For now, the debate remains unresolved. What if it is real? If the Hercules Corona Borealis Great Wall truly exists as a single coherent structure, the implications are dramatic. It would mean that matter in the universe can organize on scales previously thought impossible. It might suggest that early density fluctuations were larger than predicted. It could hint at unknown physics in the inflationary period shortly after the Big Bang. Or it could reveal that our statistical expectations of cosmic uniformity need adjustment. It would not necessarily destroy modern cosmology, but it would force refinement, and refinement at this scale changes everything. Perspective from Earth. From Earth, this enormous structure is invisible to the naked eye. Even powerful telescopes do not see a glowing wall in space. It exists only through careful measurement, data analysis, and pattern recognition. This is one of the strangest aspects of modern astronomy. Some of the largest objects in existence are not discovered through direct images, but through subtle correlations hidden in data sets. Humanity is mapping structures billions of light years away, using bursts of radiation that lasted mere seconds. That alone is extraordinary. The universe may be stranger than expected. The possibility that the largest known structure in the universe might not even be physically coherent reveals something deeper. The cosmos is not obligated to match human expectations. Models are powerful tools, but they are approximations. Every time astronomers look farther, measure more precisely, or analyze new wavelengths, surprises emerge. Whether the Hercules Corona Borealis Great Wall is a genuine cosmic titan or a statistical mirage, it represents the frontier of knowledge. It is a reminder that the largest patterns in existence are still being uncovered. A universe beyond certainty. Somewhere 10 billion light-years away, there may be a structure so massive that light itself struggles to cross it within cosmic history. Or there may be nothing more than an illusion, born from incomplete data. Both possibilities are humbling, because in either case, humanity stands at the edge of understanding. The largest structure in the universe may challenge the very assumption that the universe is simple at large scales. And that means the story is not finished. It has only just begun.